Hi, it's Gadget UK here again, back for some more Commodore goodness. So this one is an Amiga 1200. There might be a few in this video. Anyway, we'll look at this one now. It says reads workbench disk but not a game disk. So before I do anything, I'm going to take the ROMs out here, get a diagram in there and just test everything out from that side of things. But before I do that, you can see it is actually booting, so that's a good sign. Right, so I got the mouse connected up, we booted up there. You can see it's supporting 2 meg of chip. Let's test the CIAs and stuff. Now those look like they've been swapped on here. So test the IRQs, that's okay. CIA timing, yep, all looking good. So the chip RAM looks good. The next thing I'm going to do is switch it off, connect up IDE, we'll query the interface there. Not sure why the IDE LED is on all the time, that might be a clue. Going to drive tests, Gale test, not detected. Switch that off. Switch it back on again, let's just have a feel around, just see if anything's getting warm here. One or two of the chips on this have been replaced, as I said, that looks like that's been replaced. The CIAs have been replaced. So it's interesting, someone's actually swapped Gale. That is Gale, isn't it? Yeah, AA Gale. It's possible there's a damaged trace or something there for that, but yeah, this one's going to be an interesting one, I think. I'm thinking bus transceivers, but from memory I think the IDE ones might be built into Gale actually. And it's, of course, it could be that the Gale's been fitted on here, something got damaged replacing Gale, which introduced an IDE fault, as well as the one that relates to, you know, booting games from floppy. Anyway, I might just try and boot from floppy now, see what happens. So this is an interesting one. It booted from floppy without an issue. So I'm confused. I'm a little bit confused. It says it doesn't work with game disks. Let me try June. I wonder if someone used a specific disk drive with this and it's the disk drive that's the issue. But we've got an IDE fault, I think. Maybe certain games are doing something that's, I don't know, where the IDE's somehow interfering with it. I just don't understand how that would be occurring, but anyway, let's stick June in. Let's see if this boots. Get a bit of a delay there before it starts. There you go, starting to boot in. Yeah, that's working, isn't it? So I don't know, I'm puzzled. I haven't got audio connected at the moment. Let me just connect that up. Yeah, audio's working. I think we'll assume that the floppy drive is alright on this. The label perhaps on this has not been updated. Someone said here hard drive does not load. There's a cross through it and this says reads workbench disk but not a game disk. I actually think it's the opposite. I think it reads disks, I think it's the hard drive that's the issue. So I'm filming this bit right at the end here, if we're just kind of careful, try and pull this off. Yeah, the point when I tested that, you'll see we come back to that board you just looked at in the next part. There is a fault with it, it's not obvious at all. We did load June, that worked okay, and I tested a few other game disks, they worked alright. At the point when I tested, instead of the cable being that way, and it being on the 1200 like that, somehow I disconnected that, and then I think it had gone on this way like this here. Does that make sense? So the red line is still going to pin 1, this is pin 1 here on the adapter, but of course when you fit that on the 1200, the cable and the adapter come out the left hand side like that, whereas they should, I want to show you, come out the right hand side. Hang on. Like that, yeah, that makes sense. And you may think, how is that relevant? What difference does it make as long as the stripe is for pin 1 is always going to pin 1 on the board? Do you think that'd be right? But it isn't. It's the way that these cables are wired. You know, the cable comes in here, and depending on which side it comes into, depends on whether it goes to the top pin or the bottom pin first, if that makes sense. On either side, they flipped. So yeah, that is super critical. So that was a bit of a facepalm moment, but as I say, there is a fault. So the IDE is okay. Forget which way it goes now, like that. Yeah, so there is a fault with it, but we'll come back to that in part 4. So this next one is a green screen, I'll show you that. This one's going to be super easy repair. I'll show you, hang on. Switch it on. you get like a soft reset. So anyway, just watch, I just press around one of the CIAs up here, hang on, see if I can find where it is, there it is, look. And if I hold that, it will come up with the sticky disking screen. This is what I showed in a previous video about why I use a cardboard box with these boards and just press very gently in a specific location on the board as one of the very first tests I do. Look, it works. And if I let go, we got that. So it's just a bad solder joint, probably. It could be a broken trace. And I kid you not, I found that approximately 5 seconds after seeing the green screen. All it is press here on these two, like that. So you can see we've got a bit of flexion going on there. Not a lot, but that's all it needed. So my guess is it's going to be something around here, something around here. This is the RAM. So yeah, a bad solder point more than likely. So on to the third one here. This one says dark screen, tried U30, U4, U13 and replaced Alice and Lisa. So let's switch this one on. So yeah, dark screen. Is that dark? I would say it's a black screen actually. So I'm thinking with this one, it could be some sort of reset issue perhaps. Like maybe something in the convoluted reset chain there is not getting reset. Could also be the DAC actually. Thinking about it, sometimes with when the DAC goes, this is exactly what you will get, a black screen, and it can make you think something really wrong has happened to the system. I saw a flash there in the corner of my eye. Did it reset? Yeah, look, it's resetting. So it's not going to be the DAC. The fact we're getting that reset with a little bit of colour there shows there is some sort of issue. I'm just pressing down here. Look, we've got some behaviour changes from pressing again. So let's just try power cycle it. That's a normal boot there, that green line. I think that might be alright. So I think we might have another bad solder point somewhere. Just hold it there, see if it does anything more. So diagram is not booting at all, which is interesting. So yeah, I think we've got some sort of reset issue going on. Yeah, that's not booting, is it? I don't think. Normally on these you'll see like a green line flash in the middle there. I'll just leave that up. I'll fast forward this so you don't have to watch the whole thing, but I don't think that's booting. So this is about 2 or 3 minutes later actually. It's definitely not booting, black screen. I can see some problems straight away here. This resistor here is supposed to come down here. The pad's gone. They've soldered it to the pad up here, which does connect there. But then there's a pad next to it. Now they're not shorting, but they look like they almost are. Now that was the first thing, so that needs cleaning up a little bit. But then you can see these have moved here because this chip has been replaced. And up here, this component has slid into this one. And look at this here. They're joined. I don't think they should be. On both sides. So I need some. I'm just going to get this over to the mat now, get some hot air, just slide this down, see if that makes any difference. It might not be the problem, but we've got to eliminate that being the problem. So let's just focus on that one particular issue for the moment. Let's try and separate these two here. I could do with something finer than the screwdriver I've got here right now actually. But anyway, let's just see if we can separate these two from each other. It might turn out these are supposed to be joined, but I don't think so. Good grief, those are well and truly. There we go, sticking and separating a little bit now. That's it. What we'll do. So we'll just let that cool down and we'll go retest it. So the two components that were shorted to each other, I traced them, they go to Gale there actually. You can see one of them there is, it doesn't show it on here, but it goes to the IDE drive, it's the wait signal. So that was shorted to the other signal, which was the beer signal. Yeah, and you can see the underscore, you know, it's active low, beer signal there. So I'm guessing that when the CPU needs some beer, it asserts that signal. I am of course kidding, I think that indicates a bus error perhaps. You can see it here as well on the CPU. So yeah, the beer signal was shorted to the wait signal, which goes, as I say, to the IDE. It may also go to the PCMCIA slot as well, I think. But I don't like seeing shorts like that. That makes me wonder if Gale has been adversely affected. But I think not, because I think those signals would likely be in the same state, high state, unless we had a bus error. Then one of them's, you know, if we had a bus error, I guess that beer signal would go low, which means the wait signal would go low. But since that's an input to Gale, I don't see that being a problem. I think it's like an input. I think it's an input here as well. I think that's the CPU that drives those, but I think Gale can drive them. I'm not entirely sure. So this is the board that was just given a black screen. In fact, it's now just displaying a black screen again. Just a second ago we had some video. I'll just see if I can, I don't know, influence that by pressing around various places. No. Okay, let's power cycle it again. What I had up there was the graphics, actually, just very corrupted, hardly anything at all, but it was displaying something. I'm just probing the ROM here. Hang on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the ROM enable is low. Oh, let me the output enable actually. Yeah, and I see pulsing. I see activity on the data bus. So just bear with me. Just let it get a little bit further than that. There you go. Right, believe it or not, that is the start of the sticky disking screen. Just watch. You see that scrolling like that? That's the disc going up and down. You can sort of see it on the right hand side here. Can you see that? Watch. Stick the disc in. Stick the disc in. Look, and there's some text here, look. So it would seem to be some kind of graphical issue with this. Now bear in mind it's had a replacement Lisa and, as far as I can see, a replacement Alice. That's very interesting. So testing with a game here. What's interesting me is the way it's starting to blip certain parts of sprites. It's like the left hand side, and then it stretches, so you get like 1 pixel stretched all the way across by the looks of things. I think that's what's going on. So that's a clue, actually. It's going to be, if I was to guess, something related to the way it's blitzing, maybe. But bear in mind, it's had a new Alice and a new Lisa, so what we don't know is what it looked like before it had those chips replaced. Maybe it was exactly the same. But the fact that this one is booting, it's playing music, you could, at one point you could start to see some graphics there, makes me wonder, well, makes me realise it's something minor. And when I say minor, obviously it looks pretty major, but it's minor in the sense that the backbone of the system is okay. It's able to run code, it's able to do address decoding between, you know, the ROMs and the RAM, the CAS and RAS on the RAM is fine, the RAM is okay. If the RAM wasn't okay, there's no way this game would be running right now. The CIAs, again, are going to be, as far as we can see at this stage, functional. Because without timers and some of the functionality on the CIAs, it wouldn't be booting from floppy, things wouldn't be working as good as they are. So we're in the realms of trying to understand what might cause this graphical issue. We haven't got a data bus compromise either. That's very important, because, you know, that's the worst case, and the other board is a bit like that, where it's completely black screen and doing nothing whatsoever. Apart from you see activity on the buses there, so that has got some sort of major problem with a clock or with a some address decoding or a data bus conflict or something. But anyway, that seems alright, doesn't it? The fact that we've lost the video is interesting in its own right. It's weird how you don't get any video, it takes a period of time to come in, and then when it comes in it lasts for, I don't know, maybe 15-20 seconds, and you get less and less until eventually you get nothing. Could it just be as simple as the DAC? I don't know. Yeah, you can see this. You saw the circle sort of zoom out there, and you saw the left-hand side of it. So it's going to be maybe a clock related to Lisa, I think. So I'm going to go look at the schematics and report back in a minute. The soldering on this, you can see this has been swapped out and that's been swapped out. So these have got analogic stickers on which make me think these are tested, good known working parts. So then you're left with the question of, was there any pad damage around these? I don't think so. Is it the soldering? Do we need to reflow these? You can see that doesn't look so clever there. This isn't how it would be left before it was be shipped out. Someone would clean up and stuff, but obviously this was a work in progress. Someone was trying to get to the bottom of understanding the problem. So I'm inclined to want to reflow these things actually and just see if that makes any difference. And it's the same with Alice. Somebody's reflowed around Alice. So I think I might do that. I might just reflow all three of these chips here. I mean, I've inspected super closely. It's very difficult to see any bad connections there, but there's still a bit of flux around there. And it's the same on the underside. Let me show you. It's the same on the underside. Lots of things have been tinkered with, but lots of these things here look like they've been soldered. There's some vias with blobs of solder in and stuff, and yeah, it just looks like someone's been tinkering. So that's what makes it difficult. When you get in a genuine repair, I'm talking about a repair it's never been worked on and then suddenly something's failed, it's a lot easier because you don't have all of these question marks in your mind. I'm wondering, you know, we saw the thing down here with the bridge. It'd be very easy for something else like that to have happened somewhere. Maybe on the inside of some of these pins here, they look like they're not joined but there's a short, or I don't know, I might even have to pull them off yet. Well, would you believe it? I fixed it after a crazy amount of looking at the schematics here. It's looking a bit washed out actually. So there may be another issue as well, but you can see we've got video back. The issue there was the clock was missing to the DAC. It really was that simple. It's not the sort of thing that sprung to mind. The first thing I was thinking is something Blitzer related, if I'm honest. Why are the colours weird? This is the next issue with this. Don't know what I'm doing here. Let's go into memory tests. I mean, the good thing is we've made some significant progress. I thought this one was going to take me blooming ages, and it has. I've spent about 3 hours, I think, looking at schematics, and we started reflowing around Alice. So I reflowed 3 sides of it. I didn't do the final side. I thought, no, there's no way it's Alice. I don't think it's Alice. I think it's something else, which is why I started looking at clocks. So I printed off the schematics. I'll show you that in a minute, and I'll show you exactly the problem we've just resolved. But there is definitely another issue. That looks really weird. It's kind of like bright. I don't know, is it more greeny than it should be? I'm not sure this text here should be yellow. Should it be white? I honestly can't remember. So maybe we've got a colour problem as well. Again, that might be related to the DAC. Maybe someone's put a bad DAC on there or something, or maybe there's some damage around the DAC. I'm pleased though, because the first 2 boards, although I haven't actually addressed those yet, they're nice and easy. So that's 3 out of the 4 1200s that I think are going to be okay. The 4th one at the moment I'm classing as a nightmare because it doesn't do anything. There we go. So the chip RAM is okay. RGB test. Yeah, there you go. You can see the blue is clearly missing. So maybe someone's put a bad DAC on here or something. I could try pressing around there in case it's a bad solder point, but yeah, it's not looking that way, is it? It's just looking like perhaps a bad DAC. Now we've got blue, can you see that? So, I don't know, there's definitely a second issue with this though, isn't there? It's not just the clock. That's the thing with these boards though, I'm finding it's never just one issue. So, one channel, other channel. Yeah, the blue is there. So this is the following day. I spent some time last night having a look at the schematics and having to think about the problem with the DAC on this one, the colour issue. And I was convinced it was going to be something to do with the voltage reference or the analogue stuff around there. There's another pin there that says comp, I'm not sure what that is. But anyway, the VREF, this is another board. Let's see if we can get everything unshot here. So I've put the meter there, you can just about see that. If I measure this, the right hand side of this little cap here, there's 2 different variations of this. You see this little position here for an 8-pin SOP device. That's for the voltage reference. We saw the same device, I think, 1.2 volt voltage reference used on an A1200. Anyway, some of these early boards didn't have it. They seem to just stick a capacitor over here and somehow, I don't know how, we ended up with, as you can see there, 1.2 volts. Now on the other board, that one there is just slightly low. This is a working board, this one we're measuring here, and I'm doing this for a reason, because I measured the pin up here, the comp pin. On the other board there's nothing, it's 0, and if I measure here, just look at this, 3.62 volts on a working board. So I'm sure that's the issue. I'm sure on that other board, the one with the DAC problem, it's not the actual DAC. The voltage there is almost 1.2 volts. It's like 0.02 of a volt short, but it's so subtly not far off. That isn't the issue. But what is the issue is it's missing that 3.5 odd volts there. So I need to do some comparisons there next. Now if I just switch that off, one thing I did do, and here's the board. I need to finish cleaning up around there, reflowing that and cleaning all the flux away. Anyway, the one thing I did note is, and I might have shown you this, someone has been tinkering, here we go, around all these resistors here and the ones, you know, the caps and things in question that we're looking at now, this part of the circuit. So it's entirely possible a wrong component has been put on there, or a trace has been damaged or something. But I think what I'm going to do now is do some resistance measurements on these components. I'm using PCB Explorer. I'll give you a snippet of that in a minute. Shows me the layout of where that signal comes through. The comp signal comes into this 15 ohm resistor here, and then I think the pads there are joined to this cap here, and then this cap joins to that cap and that cap, and then there's some of the things, you know, obviously joined into that. That looks terrible there as well. It looks horrible blobby solder. It's awful. Flip the other board over, the working board, and I'm going to do some resistance measurements across key components there. So it might seem crazy, but you can actually measure resistance across a cap like that. If you get a difference, you know that something different, you know, there's something different in the circuit around that bit versus the other board, because it's just going to save me so much time trying to understand what has actually happened around here, because I suspect it's not the original fault. I think this is a fault that's been introduced by trying to get the video back when it was just the clock signal that was missing. And of course it could be a short capacitor, but again, if we're measuring resistance across these caps, we're going to see a difference, and that's going to hopefully be a clue. Yeah, so you can see there I'm using PCB Explorer, and you can just hover over a pin like that one there, and it tells me it's the comp pin, and I've highlighted that one that's blue. There's no traces on that side. If I flip the board over, it's a little bit slow on here. You might not be able to see for the light, but like, as I said, that cap, that resistor there, 15 ohm, and then I've highlighted its pad below, which goes to that one, and then that one goes to a wire there, but that goes nowhere, which is interesting, so I'm not really sure where that goes. But we can look at its other side, that is important, and the side of that cap goes to this cap, so then I need to see where that side of that cap goes. That goes to the positive video, so maybe we've got a supply missing to that cap, and obviously that pad there also goes to this pad down here, which goes to that pad over there. So you can see, you know, you've got to follow it around and test the opposite sides of these components and see what's connected to those and test those, and then just need to just spread out from that area there, measure things. And periodically visit the diagram as well. You know, we can look at this and see where the comp signal comes in. In fact, it's really super simple. It is on here, it is really super simple. And that doesn't fit with what we're seeing on the board, does it? If you look here, it's the 15 ohm resistor. I think that says 15, I'm sure. It looks like 25 on there. Anyway, it's that resistor there. We know that's all right. Going through a capacitor. How has it got voltage on it? This is what I'm not understanding. I'm not understanding that. It's got a wavy line there, but it says plus vid. So I'm a little confused, actually, to say the least, because I don't really understand how there would be 3 point something volts on there on the working board, unless it's the chip that provides that voltage, in which case it would be the video DAC. See, I know the VREF's okay. Maybe one of these things here, this FS adjust, or the reference, no, the reference white just goes to ground. I don't know. Anyway, I'll report back in a minute. It's getting quite confusing. Right, so comparing to the schematics, the first thing I've just checked there, I haven't done any resistance checks or anything, is this is the faulty board. This capacitor here, do you remember I was saying that 3.6 volts is missing? Well, this cap here should have 5 volts on one side, and I'm not sure if you can see that. I think you can, 5.1 volts on 3.6 on the other. And we do. There's the voltage. From here, it goes to this resistor, and then through that resistor, and we've got it there, through to the other side. So it must be a bad wire or something. It's got to be a bad wire, because there is 0 volts on that pin on the other side. Oh my god, this board is enough to drive you around the bleeding bend. I tell you what, I've solved that voltage problem, then suddenly we've got a clock problem again. The clock has gone again. And I'm like, what's going on with the clock? So I reflowed the solder from the other side, just the same. Let me just show you what I found. Where's it come out now? It comes out here, right? This is the signal, right? I was measuring between these two here. There's no join at all. These two should be joined, these components. If I press slightly, we get a join. And I'll show you this on the screen at the same time. I'm measuring now, no join, I press them together, and we get a join. Now you can see we've got stable, crystal clear video, but it's brown. So we've got another problem, a third problem related to this DAC. Oh, hang on a minute, the video's gone weird again there now. Oh, that's probably because, hang on, it might just be because that clock is making an intermittent join. Let's just try that again. Yeah, look, press them together, stable. So we're a step close, well, 2 steps closer. Anyway, I need to go bridge those two components now. So I've spent blooming hours on this. I tell you, I'm going insane looking at this DAC issue. Anyway, I think I've worked it out. I've tested so many things here and ruled so many things out. You've got some diodes here. This is the clamping network. Now it's a long stretch because the same problem happens with a composite as RGB, but I did wonder if something had gone wrong on the way to the RGB cable that meant it was shorting, affecting the signal going to the video encoder here, which would affect both. But anyway, I think you probably see a slight video difference. Well, yeah, you probably would. But anyway, I ruled out the clamping diodes, we ruled out the VREF stuff, we fixed the clock issue with that little wire through to the other side, lots of broken pads and things on there, that was all fixed. We fixed the issue here, I forget what this was for now, this wire. That was the comp signal, wasn't it? That's right. The comp signal wasn't getting through reliably. I had to feed it through a little hole there. I'll show you on the other side in a minute. And then the final thing I've landed up with is it's either the DAC or it's the connections between here and the DAC. Now, the interesting thing is, I use my portable scope, and granted, it's not very good. I really need to get a better oscilloscope at some point. I could have brought the ham egg through, and that would have revealed things. But I was looking at the colour pins all the way around. There's 8 red, 8 green, and 8 blue. The blue ones I'm focusing on because it looks like it's missing blue at the moment. And I was focused on it starts here, and then you've got 3 up here, and then it's the first 4 up the the right hand side here. Those are the 8 colour bits, and I could see activity on all of them. So I thought, well, it's not that. So because I've been rushing to get through these high volume of boards here, I didn't show everything. This was the point where I bridged these two, the tops of these here. Anchor showed there was no connectivity, and as I pressed down, the clock came back. And that gave us some stability, and then the clock went again. And you're not going to be able to see very well, but from the top of these two here where they're joined, I pulled the piece of wire around and down to the via there. And that via comes out there. Can you see that little bead of solder? So that made the clock super stable. So for that comp signal where we're missing the 3.5-ish volts, you can see I had to feed the wire from the pin on the chip here, I think it's the corner pin there, through that gap to this point here. So I think with that, it was, I don't know, another damaged wire probably, because the chip is soldered well onto the PCB. It's a bit of a mysterious one, that, but it definitely was the issue. There's definitely an open circuit between something I was measuring on this side here. I think we measured, didn't we? And we had 3.5 volts around here somewhere. But yeah, it just, for one reason or another, is not making it to the other side. So it's probably another bad via somewhere around here. Is that any more blue? I don't know. I can't tell. It looks just the same to me. So looking at the schematics again, we know we've dealt with the clock into the DAC here, and the comp signal. So the only other thing I can think with the missing blue is, well, it's either a bad DAC or it's the signals coming across. You've got 8 red, 8 green and 8 blue. Those are the 24 signals that come across here. So I'm just going to just do some, either connectivity tests, or I might actually get the logic probe onto these. In fact, even better is the scope. I'll actually scope all of the 8 blue signals just to see if they're getting across. And I've just realised this page is actually from the A4000 schematics. It doesn't really matter. The connectivity here is identical. So I'm filming this bit right at the end as well. I'm actually doing this on an A4000. The DAC is pretty much exactly the same. And if I just carefully try and get onto one of the pins here. So this is blue. I'm going to do this without shorting them. So you can see those little pulses there, that's one of the blue bits. And I'll just go around and show you a few of these. That's like another one. Can you see the little pulses? And there are 8 of these, and they're all on the same side for the blue. Some of them, obviously, like that one there, are obviously used more, and that's because, you know, obviously there are 8 of these, and depending on the colour that's shown on the screen, on the various parts of the screen, dictates what those will, you know, how much activity there is on each bit. But as you can see, there's something on all of them, and that is exactly what I found on that DAC. I'm going to remove the DAC from the 4th board, the one that's not doing anything. This has lots and lots of things replaced on it. It's had both CIAs, the video, the keyboard controller. That's been swapped, that's been swapped. This looks like this has been swapped, so it's certainly reflowed. And this may even be new, I don't know. So I'm going to remove the DAC from this one. I've got Captain tape around these things that could be subject to a little bit of heat damage, and I'm going to remove this. Tell you what, let's just get a little bit of flux around there. It's going to help, isn't it? Certainly with this type of chip, it will make a big difference. You know, a small like 4-pin device or an 8-pin device, you can get away without any flux, but this thing will be difficult to remove. I've got no doubt. Phew, I thought that was never going to come off. I seriously thought that was never going to come off there. Got a floating pad there, look. All the other pads are okay. So I removed it from the other board as well. That was a nightmare. It took blooming ages to get it off. I've cleaned up the other one, as you can see here, cleaned off all the flux and solder from underneath and stuff, so hopefully that's okay. Just need to work out where pin 1 is on there. I can't see it from here. It's on there, isn't it? And then pin 1 goes on the side, so it's going to go that way up. So yeah, I'll just get that into position, anchor a couple of diagonal opposites, and then do some drag soldering. And there we go. I'm glad I followed my instincts. I was right. And let's just say, when I was probing the signals there, I did see activity, all of the same sort of voltage levels, so it had to be the DAC. But you know what? You doubt yourself. All the while I was taking ages to remove that chip from the other board, and then ages to get it off this board, and then quite a while to get it back on. I need to clean up the solder next. Yeah, you doubt yourself, and I was thinking, oh my god, I bet the colour problem's back again, but no, it's not. That's the final piece of the puzzle on the colour problems on this board. Rock solid, crystal clear display now with the correct colours. So I'm just going to have a little bit of a clean up around here. You can see it's very fluxy, but can you see some of these components up here? Let me zoom you a little bit. Yeah, hopefully you can see the solder's pretty blobby on some of those. Some of those look like they've been took off and replaced, so I'm just going to equal the size of the solder on some of those things there, and then we'll get the scrubbing brush and IPA and have a good brush around this whole area, because this flux leaks everywhere, and it's obviously under and around that whole chip, but you can see the pins are soldered pretty well on it. So I've cut so much, I didn't show the soldering there, but you know, we've got other examples within this series here of the similar sorts of soldering, and I'll post some links above and below to other videos where we've done similar sorts of things, but I've actually shown more. So I reflowed all those components there, got rid of all the blobby, sticky outy bits and stuff, and yeah, it's just looking pretty good actually. It's looking almost factory, apart from that one wire. So, another progress update. The green screen, we were pressing around here. I reflowed this chip actually, all the way around. The solder points aren't very good on it, but they weren't originally. Didn't make a difference. I reflowed all four with some flux and hot air, didn't make a difference. And then I pressed on these end pins. I thought it's going to be an end pin, and I pressed here on this pin. Suddenly the green screen went away, and it stayed away. I thought that's definitely what it is. I reflowed it, and it's not been back. So I'm sure that's what the fault was, it's this corner of this chip here. But there is another issue with this, let me show you. It's annoying, it's been the same with every one of these. Watch, I move the mouse, look, you can see the left button's pressing. The left button clicks all the time. The other thing is it's not detecting the expansion RAM. Now I don't know whether that's something to do with the left click being held down at boot or what. I honestly don't know, it could be a separate issue. But anyway, if I press down on the shift register, just watch, it works. I let go, goes back, I press it. And there's the shift register there. As I'm moving the mouse around now, it's flickering that left button, even though I'm not pressing it. And I press that down, just like that there, stops, back, stops, back, stops. So I'm just going to go get some flux on there. Hopefully this board will then be 100%. The solder points don't look clever on there, but it looks like someone's reflowed it. That's the weird thing. And of course the other thing we've got to deal with on this is this expansion port. Yeah, I'm just going to bob into them and just drag outwards like that. This is obviously two issues now related to bad solder points, so I'm not really sure what would have caused it. It's a bit difficult here because of those little transistors. I'll just drag this way if I can. Yeah, I just need to clean up with cotton buds and go and test it. So this controller problem, it wasn't that little SMD chip. You can see it's still doing it here now. Hang on, let's go back one. Oh, it's really annoying this. If I go into mouse joystick, so you can see when we move, it's doing that. So the temptation there was to think it's the left mouse button, and that's what I've just been trying to follow. And I reflowed the caps and things, and I've reflowed the connectors and all that. Didn't resolve it. And the caps, let's say, the cap and resistor that relate to that button. It's not the issue. And I just remembered that what you can get with this is when one direction is an issue, it fires buttons and things like that. So if I just change it to the joystick test, if I click there once, hang on. Right, so on the joystick test, unplug the mouse, plug the joystick into the mouse ports. You'll see nothing is highlighted there. And if I press left, that works, down, right, fire, fire's doing up, but up, it's doing fire. So it's not, that's the clue, it's not just the fire button, it's the up direction as well. So now I'm armed with that information, I can go and look at the PCB, follow the connections from the up direction on the joystick port through onto the PCB and work out where those go. And again, there's going to be a cap and a resistor or something on those. It's probably going to be a bad connection on one of them, just like it was on Williams A1200. I'll stick a link up there to that video. So the components in question are those two there. These two edge ones here I think were for the button. And I tried reflowing those already, it didn't make a difference, but these two here. So I suspect, just looking at that cap there, you can't really see, but the solder on this side just looks really weird, as if maybe it's come loose. So I think if we just get a bit of flux on those and reflow those. I'll reflow these things again as well because they didn't have any flux. I'll get a flux onto these things here and just reflow these again because they look a bit beady as they are at the moment, you can see. So I'll have some flux there, and I'm just literally just going to reflow those two components there. So I got the wrong one, didn't I? And while we're here, as I say, I've got some flux onto these things here. This one's driving me nuts. I'll show you here, just watch. Continuity. These are the two things in question, the buttons. One's up and one's fire, I don't know which way around they are. And there's a short here. So I've eliminated this thing here, because this is what, as I showed earlier, I was pressing on a certain part. and it fixes it. So it's definitely a connectivity thing, but those are joined, they shouldn't be. Now they come down to these components here. You've got the first set here, and those pads are joined, that's correct. One side of ground here should go to that cap and that cap, that's correct. Doesn't go there, doesn't go there. These are the two resistors, one for each. So those two resistors, they're joined. How are they joined there? They're not even read by the same device. Those aren't joined. There's hang on, let's just put on resistance mode. 130, 140 ohms there. On that side there, 12 ohms. So, what is going on? Are they glued down? No, that one's come off, look. Can't get it off now, that's it. That's one. And this one's the other one. And that's two. So let's just see if the short's gone. Now the short's still there. So it's not those caps, is it? Now I'm not sure if this is the next obvious thing or not, but I'm thinking take this connector off. I'll tell you why. Can you see there's a row here? This is designed so you can have the pin header thing and then stick a cable on, or you can have the edge connector here. And obviously we've got a short there. I wonder if there's been a bit of solder here. Now that might seem unlikely until you look at these here. Can you see? Look at the solder on that. It's terrible. It's like someone's been tinkering with the solder on here. And the way that some of these are filled and not makes me think that that's had a different type of connector on at some point. Someone's swapped it over maybe. So I think I should remove that just to rule that out, because the traces here, there's no way they could be shorting. This is the mystery with this. I mean, I'll just clean these pads up before I do that, just to make sure there's nothing obvious there, but they go different places on the board, so I don't really see how they could be shorting really. So I'm sorry I've had to end this on a bit of a cliffhanger. Will we fix the mouse? Well, you know we will. So yeah, in the next part we'll continue looking at that issue. It wasn't what I thought it was going to be, to be honest. There's also the fourth board, which was an absolute nightmare, as you will see. But yeah, I think I tackled it fairly well, actually. Now there's also the one that I couldn't really find anything wrong with, the one that said it had a problem loading games but not Workbench, and I thought there was an IDE fault. Anyway, we come back to that one in the next video as well. So I'd like to thank Stefan and Raj again. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I hope you found the video interesting. I'll catch you in the next one.